So I wanted to give you guys some directions on the Anole Lizard Lab. This is assuming you've watched the first approximately 10 minutes, it's just shy of 10 minutes, of the video from HHMI that introduced you to the lizards and then the different ecomorphs. So ecomorphs meaning body type. And so like a trunk ground is one ecomorph, or a trunk crown is another ecomorph, or a grass bush is another ecomorph. So first of all, these lizards that we're going to be looking at are all in the Caribbean Ocean here. So we're going to be looking at Cuba, which is right here. Here's the tip of Florida for a little bit of geography reference. And then Jamaica is here. This island, which includes two countries, Haiti and the Dominican Republic, that's known as Hispaniola. And then finally is Puerto Rico right here. So I just wanted to give you a frame of reference of where these are in the world. So you can see they are pretty close to one another. So if we were in class, we would be giving you these 16 cards that have, I know there's only 8 here, I'll show you the other 8 in a minute, but these 16 cards that have 4 different ecomorphs on them from 4 different islands. So there's some grass bush anoles, there's some trunk ground anoles, so you can kind of see them. Some of them blend in really well. And you can see their genus and species. So they're all the genus Anolis, meaning they're pretty closely related. And then they all have a different species. So like Sabotes here, that's the species for this particular trunk ground anole found on Hispaniola. And then this is a Cuban trunk ground anole, and it's Anolis sagre. So they all have the same genus. They are all anoles. These 4, right, are all trunk ground. They're all the same ecomorph, but every one is a different species. So there's 16 different species, all of the same genus, 4 different islands, 4 different ecomorphs. So those are the grass bush and the trunk ground. If you want to go back and look at them later, you can come back to the video. These are the twig and then the trunk crown. Right, the trunk crown obviously end up being green so they can hide within the leaves. And then you saw in the video, they have different tail lengths, they have different leg lengths, they have different toe pad sizes, and all of those are adaptations that help them survive. So as I said, if we're in class, we would be having you sort these in a group, and then we would stop and we would discuss and we would talk about why did you sort them that way? What did you think? What did you think? Does anybody have the same group as you? Etc. and so forth. We have skipped all that because we are not in class. We are in class. We are just in modified class. So what you're going to be looking at is you first need to develop a prediction or a hypothesis as to why the similar ecomorphs can be found in different Caribbean islands. So in other words, who are more closely related? Lizards of the same island but different ecomorphs, or lizards of the same ecomorph or on different islands? And one more way to look at this, I'm just repeating it a couple times because I know from previous years people get confused sometimes. Like if we're looking at these lizards, are these 2 trunk crown lizards more closely related because they're both trunk crown, or are these 2 lizards, the Anolis occultus here and Anolis evermanni, more closely related because they are both from Puerto Rico? And one thing to keep in mind, and this is, you can see this because they're all Anolis, right? These are all lizards that are very closely related. They are more closely related than a different kind of lizard, say a gecko, for example. But we're looking at what are more closely related, okay? They are clearly all related. And in fact, if you watched the Neil deGrasse Tyson video, you know, all life everywhere are related, right? These lizards are related to this tree, but these lizards are more closely related to each other than they are to the tree. So we're looking at which lizards are more closely related. So pause the video, make a prediction, or actually you don't even need to pause the video, sorry. Just know that you should make a prediction before you start your coloring. So then when you're doing your coloring, you have this worksheet with this chart on it. Now you have this phylogenetic tree, and you have this exact same tree twice because you're going to color code it by island and then you're going to color code it by ecomorph. Don't worry what these numbers mean. If you really care and you want to discuss it, that would be a great office hours topic. But we're not gonna worry about them right now. So this tree was made based on Anole DNA. And also, if you are curious, I can show you, like, I made this tree, not personally, I put all the Anole DNA into a phylogenetic tree maker, but I can show you where I get, like, I think if you Google Anole DNA sequences, you'll come up with sequences. It's not all the DNA in the Anole, obviously, but like it's certain sequences that are online. So, for example, if I'm coloring this by island, I'm going to look and I'm going to say, okay, Anolis allotaceus is from Cuba. And I'm going to color all the Cuban anoles yellow. So here's allotaceus, so I'm going to color that yellow. And then the next one is Angusticeps, also from Cuba, so I'm going to color that yellow. And then another one is Ophiolepis. Where was that? So I'm going to color that yellow and so forth. But then I'm going to take like the Hispaniola lizards and I'm going to color all of those orange. Ooh, that looks too much the same. I'm going to color all of those red, okay? So the first one is Chlorocyanus, and so that one is right here. So I'm going to color that one red, and so forth. And I'm going to do that for all of the islands. So I'm coloring them by island. Then I'm going to go to my other phylogenetic tree, which again is exactly the same. And I'm going to do the same thing, but by ecomorph. So I'm going to color all the grass bush anoles red. So then I go and I say Allotaceus is red. Where's another grass bush? So Olsani is red. So that's here. But then maybe I'm going to go and I'm going to color all the twig anoles yellow. So Angusticeps would be yellow, and so forth. So by the end, I should have two phylogenetic trees, same phylogenetic tree, but color-coded, and I'm going to use that to then gather data on whether the lizards, let's go back, are more closely related by island or by ecomorph. So that's kind of what you're doing. And this is going to kind of bring together how we use DNA, how we use phylogenetic trees, and how we can use those to then see how different lizards are related. One thing I do want to say is a lot of people will automatically, and I'm not saying it's wrong, but will say, well, of course they've got to be more related by island, because how would lizards get from island to island? Remember, organisms travel all the time from island by island. These islands are really close together. In hurricanes, as you saw in the video, a lizard can literally be sitting on a log, get swept out to sea, and end up bumping up against Haiti, and then climb off here and start to repopulate Haiti with its species. So keep in mind that these lizards developed over millions of years, and so there's plenty of time for lizards to have inter-island travel. And so just don't let that get in the way of your hypothesis if that's what you're concerned about. Okay, so now go ahead and you can make your prediction and start coloring, and then you're going to watch the last like 8 minutes of the video once you have your ideas out.